Hello, my name is Paul Erwich and this is my final video for AT. This video showcases the two projects I created for AT, starting with engagement in Steam and then generating game assets with AI. Firstly, engagement with Steam. The project is titled, How can augmented reality be used to increase engagement in teaching geometry for a younger demographic? Geometry is a core part of the UK mathematics curriculum. It requires students to identify several features of various shapes and perform calculations with them. Augmented reality is an emerging technology that provides users interactive and engaging experiences different from the traditional methods of listening and reading. The project developed as an AR mobile application designed to increase student engagement when learning about geometry. By connecting the physical and virtual space, it aims to innovate teaching in a new and exciting way. Looking at the UK curriculum, students are expected to identify 2D and 3D shapes along with knowing key features such as width, height and depth, and performing calculations such as area, perimeter, surface area and volume. The mobile app allows the user to scan various Pokemon cards in the real world. The application then attaches virtual representations of 2D and 3D shapes to them in the virtual world. This allows students to perceive what the shape would physically look like, providing a bridge between theory and practice. Through the user interface, the user is able to view information about the shape currently being tracked. Provided buttons bring up calculations for area and perimeter when viewing 2D shapes, and surface area and volume when viewing 3D shapes. There's also an additional button which changes the shape's dimension, from 2D to 3D and vice versa, allowing them to view relevant information for the shape they're currently viewing. The cube and tetrahedron have additional features as a proof of concept. They have visible labels for the width, height and depth, and by touching the shape in the mobile app, it will trigger an animation where the shape folds out into a net, clearly showing how the 2D and 3D versions are connected. The application was developed in Unity, as it's known for being easy to develop mobile applications with and allows for quick prototyping. It is also the engine the Vuforia plugin is designed for. Vuforia is a plugin designed for fast and easy AR content development. The image tracking capabilities are an integral part of the project. The plugin allows for images to be connected to shapes within Unity through the use of a parent-child system. When the parent, which is the physical card, is found, it shows the child object, a virtual 2D or 3D shape, in the virtual space. When an image is tracked, a reference of it is passed to the user interface, so the information regarding its calculations can be displayed correctly. The user interface is made up of a simple canvas which has a header for the currently tracked object, along with 3 buttons for the user to use. These include a way of changing the dimension from 2D to 3D or vice versa, and 2 extra buttons for the calculations relating to the current dimension. The shapes are split into 2 parts, 2D and 3D. 2D shapes contain a sprite and a script containing information regarding lengths such as width and height, and the calculations required for the area and perimeter. As each 2D shape has different calculations, there are inherited scripts for each one. 3D shapes contain a mesh and a script containing information regarding their lengths, such as the width, height and depth, and the calculations required for their surface area and volume. In the case of the cube and the tetrahedron, there's also an additional animator that allows them to fold out into nets. Further development of this prototype would include adding nets for 3D shapes that do not currently have one, adding more shapes to cover everything required by the UK mathematics curriculum, improving the user interface by adding colours and making it more intuitive, and finally replacing the Pokemon cards for pictures of the shapes they represent. In conclusion, by creating this visual representation, the user can create a clearer picture in their mind of how the shape looks, what its properties are, and how they are used to calculate features such as area and volume. I believe this can be a powerful tool to improve student engagement within the teaching of mathematics. Thank you for watching. Now, on to generating game assets with AI. The project is titled Dungeon Layout Generation using Generative AI. Generative AI has emerged as a powerful tool. It can be used in a number of applications such as text, song, and image generation. Generative AI for game assets is a growing topic of discussion within game development, with its users both being tested and scrutinized. The project developed looks at generative AI for the application of dungeon generation. Through the use of unconditional image generation, a system has been developed that combines a Python-based model with a C++ procedural generation algorithm. Looking at generative AI, the requirements of such a system would include a model trained from a bespoke dataset of images, and a C++ program with an algorithm able to produce a variety of dungeon layouts to show the effectiveness of the generative AI. The Python project adapts a Hugging Face tutorial for butterfly image generation. This utilizes the UNet 2D model architecture to generate images without the use of user input. The newly trained model is able to output various dungeon layouts different from the original dataset, allowing for unique dungeon room layouts to be created. These images can be created within the C++ program via the running of a Python script. Once run, the generated images are sorted into various folders depending on the type of room they represent. When a dungeon is generated, images from the relevant folder are randomly selected, providing variety every time a layout is created. There is also a pre-made layout, which showcases every type of room available. As mentioned, the Python project adapts a Hugging Face tutorial for image generation. The main adaptations to said tutorial are the creation of a bespoke image dataset, changing the pre-processing steps to better suit the dataset, and changing the images from RGB to grayscale. The bespoke image dataset is required to train the model. Each image is 32 by 32 pixels and uses black for walls and white for the floor. These are the main features of every dungeon room. There are also 4 pixel wide gaps centered on different sides to represent doors. These are important for the C++ program so it can detect which types of rooms the images represent. The pre-processing steps are applied to images before they are sent into the model. This allows for the dataset to be artificially increased. All the pre-processing steps have a random chance of being applied, so the original images can still be passed in. Pre-processing applies transforms to the images, such as rotation or flipping, so there is a lot more variety per image in the dataset than would be originally perceived. The images were changed from RGB to grayscale, as the colours are not required for the layouts. The 256 possible colours from grayscale are more than enough, and by removing the 2 extra channels from the model, it greatly reduces the training time, which is one of the biggest drawbacks for training a bespoke model. The C++ program reads in generated images and uses their pixel data to visualize them. When an image is generated, 3 algorithms are performed using it. The first checks what doors are available by checking the 4 pixel gaps previously mentioned. The second runs a pathfinding algorithm between the doors to ensure a player could get between them if used in a completed game. The third moves the image to a folder based on the number of doors it has, and those doors' orientation. There is also a procedural generation algorithm that can create a 5x5 grid of dungeon rooms. Generated images are then assigned to the rooms based on their requirements, and displayed to the user. Further development of this prototype would include adding additional colours to the dataset to represent more features, such as enemy spawn points or loot, and creating a secondary model to generate rooms of different sizes. For example, a 64 by 32 size room that would take up 2 spaces in the grid. This would allow for greater variety during dungeon generation. In conclusion, generative AI can be a powerful tool for developers. This prototype shows how it's possible to create a bespoke dataset and train a pre-existing architecture in a relatively short time. It provides a strong use case, and it will be exciting to develop further. Thank you for watching.